folks, it's my pleasure today to welcome Moez Ali to this online session of the Synthetic Intelligence Forum. Thank you for taking the time to join us. Moez has been very active in developing this very interesting solution called PyCaret. And PyCaret has really been taking off for a while, but nowadays, if you look on the social media, you see that it's truly doing quite well. Lots of engagement, lots of likes, lots of interaction. And if you look at the GitHub repo, there's plenty of activity going on there as well. PyCaret was essentially designed as a system to help citizen scientists and indeed also help professional data scientists. We know there's no shortage of data science tools out there, but really to have a tool that helps you to increase productivity, is easy to use, and is business ready with that as a design perspective in mind from the very beginning, that is really, really awesome. So I'm very happy to actually welcome to our stream Moez Ali. Moez, welcome.
Hey, thanks, Vic.
Yeah, pleasure to have you, Moez. And I'd just like to start by saying, when I was getting into the machine learning world, I used to look at packages like Torch and packages like TensorFlow. And I always used to wonder, what types of developers are the colleagues out there who are making these solutions. And it's great that we actually get to have the benefit of someone like yourself who has built a package like that. And just so you know, some colleagues on the call, viewers may actually know about PyCaret. And before you dive into some of the more complex concepts, I would love it if you could maybe warm us up and tell us a little bit about PyCaret, more from an introductory perspective, and then dive into a much more detailed view. So without further ado, Moez, I'm going to pass the stage to you, and then we can share your screen.
Thank you, Vic. Let me move to my presentation mode. Okay, can you see my screen?
Yes, absolutely, Moez.
All right, and thank you everyone for joining today. Thank you, Vic, for inviting and organizing this session. I'm really pleased to be here, and good evening and morning, depending on where you are joining from. We have a very packed schedule for today, so let's get directly into presentation. Okay, a little bit about myself. I'm an analytics leader by day and a very passionate data scientist by night. I'm a very active open source contributor. My most recent open source contribution is PyCaret, which is a Python library, and this talk is about that. Originally, my background is in finance, so I'm a member of CPA CMA Canada and ACMA UK, and I have lived and worked in 4 countries and have spent most of my career in analytics and reporting role. I'm currently based in Toronto in lockdown, and I'm very active, as Vic pointed out, very active on social media. So if you would like to connect to me on LinkedIn and Twitter, here's my profile. Would be happy to meet you with guys. All right, some important links for today's sessions: our website, GitHub, LinkedIn, YouTube. But the most important thing here today is this link: github.com/pycaret/pycaret-demo-sif. So this presentation and all the demos that we are going to do today is uploaded on this GitHub repository. So if you would like to follow along, you'll have to clone this repository. There are notebooks there. So feel free to follow along if you want. But if you don't want to follow along, this presentation and all the material that we'll cover today would be on this GitHub repository. And towards the end of the session, we'll also post the link on the chat group. All right, and if you'd like to follow PyCaret, there's a hashtag PyCaret on LinkedIn that you can follow if you'd like to get continuous update about PyCaret. Okay, so in today's session, we'll only be able to cover so much, but there are a lot of resources on PyCaret, video resources or written resources, and most of our resources are usually written or videos are constructed in a way that beginners can follow. So most of our work around very introductory. So even if you have no background or you're just starting out, these tutorials are written in a way that you'll be able to follow right from installation until end. So if you're interested, I encourage you to go through these resources, and there are a bunch of them, and they are hardly like 10 or 15 minutes read. So really bite-sized tutorials. I'll leave it there for you to follow along if you want. Right. Okay, so today's agenda. So I know few of you would know about PyCaret or would have used it, but I'm assuming that most of the people would need some kind of introduction to PyCaret. So we'll go a little bit about what is PyCaret, what problem it is solving, Then I'll talk a little bit about new features that is coming up in PyCaret 2.0. So PyCaret 2.0 is like 2 or 3 weeks away from today. So we'll talk a little bit about it, not deep dive, but we'll show you. Then we'll do one demo using PyCaret 1.0, and you can follow along that demo. There's a notebook on our GitHub page. And then we'll deep dive into the second part of this session today, which is deployment and why do we deploy machine learning models. And in that conversation, we'll also cover what is a container, what is Docker, what is Kubernetes. These are the terms you have heard before, and if you don't understand them, you're today in a perfect place, because we're gonna talk about that. And then we have 2 deployment demos, one on Heroku. Heroku is also a platform, we'll talk about that, and one on AWS Fargate, which is a serverless infrastructure of Amazon. All right, and then we'll end the session with Q&A. Okay, so let's get it started, and I'll pause here for 60 seconds. If you would like to clone the repo, here's the link again. And if you don't plan to run the notebooks locally, you want to do it on Google Colab, you can go to pycaret.org/demo. There are links to notebooks there, and you can just follow along on Colab if you want. Okay, and if you haven't used PyCaret before, you can use pip install PyCaret in your Jupyter notebook or Anaconda environment to install PyCaret, and it takes usually 5 to 10 minutes. I'll give a minute pause here for people who are trying to clone the repo.
Moez, that's wonderful that you are brave enough to have a live demo where people can actually follow along. So there's no vaporware. Everything is real. Everything is true to form.
Yeah. When we were building PyCaret and it's internally, when we talk in our team, and one of the biggest thing about PyCaret was I always used to tell my team, I'm creating it in a way so that when I'm demoing PyCaret, I don't need to have pre-written code. So it's that simple that I can take the risk to do it live.
Absolutely. Well, I just wanted to make that compliment. Great.
Thanks. Okay. All right. So let's start then. Okay. So this is our machine learning model development lifecycle that I'm sure most of you have seen before, starting from business problem and ending with deploying data on your right-hand side. But what we are going to talk today is this part, specifically training, tuning, and deploying. Whatever happens before this is obviously pretty much the same. You build your ETL, you do visualization. It's not covered in today's talk, but we're going to zoom in this part, which is training machine learning models, and we're going to see what is the granular life cycle. So this picture is a broad or a very high level overview of a machine learning project, but we're going to see the granular life cycle of a supervised experiment. So typically a supervised machine learning experiment would start with defining business problem and converting it in some kind of ML objective, or linking your business problem with your machine learning objective. Then your normal collection of data, analysis of data, and then you actually start your real training would start from this train test split. You would split your data set in train test validation depending on what kind of processes you are following, and then you would classify different data types like categorical data types and numeric data types, because in machine learning there's really great significance of data types. If you don't handle them correctly, you end up messing up data. Okay, then you impute missing values, you perform encodings, you scale your data, perform different kind of linear or non-linear transformations depending on the data set. You do feature engineering, feature interaction, feature selection. You do zillion other things, right? As you are doing all these things, you are constructing something we call pipeline, right? Going on, once you have your final data set which you want to expose to algorithms, which is your transform data set, you start a model training, right? And when you start model training, you set up some kind of cross-validation environment so that you can track performance of your models as you are training them. Then you enter into the loop of hyperparameter tuning. Again, you track performance, you try different on-sampling methods. Again, you track performance, you blend models, you stack models. No matter what you do, you track performance, because your goal at the end of the day is to finalize best model and deploy it so that somebody in business can consume that model and benefit, right? And there could be different criteria on selecting your final model, like metrics. Performance metric is just one of them, but in terms of business, you could have explainability criteria, you could have inference timing. There could be many other things based on which you would finalize. But for today, let's assume that we're gonna finalize our models based on accuracy or AUC, like a simple metric, right? Okay, the problem is you do this process on a repeat basis, because you never build one model, or when you are starting your experiment, chances are you wouldn't know which algorithm would work better with your data set, right? So you end up repeating this process multiple times until you actually finalize a pipeline that sits well with an algorithm on the given data set. And it's obviously with every data set, that pipeline or that your best performing model would change, right? So when you start doing this on repeat basis, the problem is, and not the problem, but the challenge is, machine learning is really iterative process, right? You never know on day one what thing is gonna work. So that's why it's called experiment, right? You have to work through it. And it's mostly about asking the right questions. The problem that I was having last year when I was going through my final year of school, and as the idea of PyCaret started, and the motivation behind it was the shift that is happening in the inflow of data science, right? So almost 50% of students in university are now coming from non-quantitative background, right? They're not coming from statistics or computer science background, but they do really have domain knowledge, which is really key in solving problems through machine learning. But the problem was the current tools in the market is not really business-driven tools, right? And if you're coming from a computer science background, you may find things like scikit-learn or TensorFlow really easy, but that's not true across the board, right? It totally depends on your background. The other part is all the steps that you have seen here. You have to perform them, and perform them in a way that is reproducible, right? And then you have to maintain the sequence as well, because if you are performing these steps today, it's not just for the training. You have to have a pipeline that can replicate these things when you have new data coming in tomorrow on which you have to predict. So creating a seamless pipeline is hard, and managing it is really hard. And we'll see in demo next how PyCaret can really solve that problem for you. Okay, and the last thing is, the current tools are not business friendly, and domain expertise play big role in machine learning. But the problem is, I don't see that domain experts or business experts are empowered in a way that they can do quick, rapid prototyping by themselves without being dependent on IT or main data science function. Okay, so what is PyCaret? So PyCaret is an open source, low-code machine learning library in Python that aims to reduce cycle time from hypothesis to insight. All it means is it is supposed to make you really, really fast and quick, and it allows you to do rapid development of the machine learning pipelines or models, right? And when I think about PyCaret, or maybe let's put it this way, what I want people to think about PyCaret is it's easy to use, so essentially no learning curve. It's a productivity tool. It's easy, but it's not basic. That means if you are a professional data scientist and you're already doing some advanced stuff, you can easily take PyCaret and plug it in your existing workflow or pipeline. It would save you time, right? And it's a business-ready solution, because the way it's being designed, that's the real power. The way it's designed, it's more intuitive, right? And this is one little experiment of effects of using PyCaret. So on your x-axis, these are stages, or this is the workflow of a typical machine learning experiment, which starts from setting up your experiment, doing EDA, pre-processing, multiple model training, tuning, and those two lines here represents. Blue line is our base, our base experiment using scikit-learn, and red line is PyCaret. On your y-axis is the lines of code. So basically, to perform the same experiment, you would write 170 lines of code using scikit-learn versus 23 lines in PyCaret. So this is the experiment. And this one, the graph on your right is a productivity curve. So all it means is when you perform experiments, and we repeated this experiment with 10 seasoned data scientists, and these numbers are average. When you perform experiments using PyCaret, unit 5 is the hardest level of experiment that we set. So we basically set a couple of tasks, organize them in units, unit 1, 2, 3, 4, 5, and unit 5 is the hardest, or maybe the most lengthy, right? And when you perform experiments using PyCaret, for supervised experiment, you can see 8%. This is 8%. You take only 8% of the time that you would take otherwise. So same thing showing productivity, but the left graph is lines of code, the right graph is time. Okay. Some facts about PyCaret. It started last year summer, written in Python, completely written in Python. There are no wrappers at the moment for other languages, but future version, it looks promising that we might have wrapper for other languages. Project took approximately 1 year to complete until PyCaret 1.0, and we are actively building. So we are currently building very actively for 2.0, which is like 2-3 weeks away from today. Completely self-funded so far, and supported by a team of brilliant people, not just coders, but people from a variety of walks, people who have helped us design PyCaret, people who have helped us with documentation. So excellent people. If you'd like to contribute, follow this link. It's an open source project, always in need of contributions. Okay, some new features in PyCaret 2.0. The slide is just there for completeness. I'm not gonna go through them today, but there is a session tomorrow. The slide is here. And tomorrow's session, I'm going live on a YouTube channel with Abhishek, and I'm gonna talk about 2.0 features, and I'm gonna walk through the new feature set. So if you guys are interested, please feel free to attend this talk. It's happening 9:30 p.m. IST tomorrow. Okay, so let's get into the demo. And once again, if you are planning to follow along, this is the repository. You can clone the repository, or if you want to use Google Colab, you can follow this link, and there are links to Google Colab notebooks. If you are using Mac, you may have difficulty installing LightGBM, which is open source framework from Microsoft. In that case, if you go to our install link, there are instructions on how to build LightGBM from source if you are using Mac. Okay, with this, let's get into the first demo for today, which is this. And let me put it on full screen. Okay. So if you are following along, the notebook name is PyCaret classification demo, right? Okay. So the first cell here, import version, very obvious, checking the version, it's 1.0. With PyCaret, we have certain data sets that we have uploaded on our GitHub repository, and we use them during demos so that you avoid the hassle of loading CSV. So this function here, get data in PyCaret datasets module, would basically get you whatever dataset is on our GitHub repository, and there's a list of available datasets. So if you would see this from PyCaret datasets import get data index. So here's the list of all Troy datasets. And the reason we do this is we don't want to download all the datasets in your computer when you install PyCaret. So that's why they are on our GitHub. Obviously, you need internet to access these datasets, right? So today for this demo, I'm using dataset called juice. I'm just loading juice. So each row here in this dataset, each row here is a transaction at a store, right? And it's a retailer. And the target variable or our objective here is to predict what kind of juice customer would buy. So CH is one type of juice, MM is other type. So it's a binary classification problem. And all these are attributes, right? Based on which you have to predict the juice, right? And if you look at this data set, there are a couple of problems outright. This target variable, you have to encode it 1 or 0. You cannot just use it directly. There are a couple of other columns which are strings or binary. We have to convert them to some kind of encoding, right? And there could be missing. In this data set, there are no missing values, but normally, if you have missing values in your data set, you have to impute them first before you can actually start model training process, right? So this is the data set. Our objective is to build a binary classification model which can predict what kind of juice customer will buy, right? Okay, in PyCaret, everything starts with initializing the environment. And when you initialize the environment, that means you initialize it through a function called setup. And this is very consistent across all the modules in PyCaret. So there are 6 modules in PyCaret. That means there are 6 machine learning tasks that you can do. The classification, regression, clustering, anomaly detection, NLP, and association rule mining. All of them has exact same coding style. So basically there is no learning curve. If you can do classification, you can literally replicate this code for any other module, right? Okay. So first line here, I'm importing everything from classification module, PyCaret.classification, import all. And if you are coming from a computer science background, you must be burning now while I use this star symbol here. If you don't like it, don't feel obligated to use it. You can import individual functions like this. But uh, if you're doing it, that's totally fine because PyCaret is a function. It's functionally written language. It's not OOP. It's functionally written. So the reason I prefer to import everything when you're doing your experiment in Notebook is so that you have all the functions available to you, whatever you want to do, right? When you are promoting it into production, and there is a reason you don't want to use the star in your production environment so that you can trace back, there you can replace it with a specific function. But when you are experimenting in Notebook, there is nothing wrong with importing everything. But if you don't feel like doing it, feel free to import individual functions. But I'm going to import everything because I want all the functions to be accessed by environment. Okay. So this function setup takes 2 variables: the data frame itself, which is this, is stored in data variable, and the target, which is this, right? And you realize at this moment, this entire thing, it's not transformed in any way. But as soon as we run this code, PyCaret would infer the data type for each column. And if we are okay with the data types, assuming we are okay, you can just press enter. What it does in background is transform the entire data set so that it is used, it can be used for training by all the algorithms. And it would do a couple of other things if you ask it to do. So by default, it would do a couple of steps. So one is imputing missing values. The other is encodings and transformation. So these 2 are really imperative to start model training. So it would do that by default, but there are at least 25 or 30 other transformation options that you can use inside this. So this is the list. So you can do PCA, you can deal with high cardinality features, you can normalize, you can transform, you can do nonlinear transformation, you can combine rare levels, you can remove outliers, you can create clustering features, you can do feature interaction, you can do anything, right? And it is as simple as putting those parameters in here. So for example, in this case, we haven't done anything. And this information grid basically shows that original data was 1070 by 19. That means 1070 instances and 19 columns. And when we transformed it, it split it into training and testing set of 748 to 16 to 22, 16, right? But if I want to create new features in this data set, it is as simple as writing feature interaction true. And now when I run this, you realize that in transform data set, now I have 22 columns because from 16 earlier, right? So it created those 6 or 7 new columns automatically, right? Just by interacting numerically. Similarly, there are other things that you can do. I'm not going to talk about those specifically. Our website has very good documentation, very intuitive to understand. So if you want to learn more about this specific function, website is best source to start with. Okay, so assuming you have initialized the setup, that means you are now ready to start modeling. Our recommended first step in PyCaret is this function here, compare models, right? And let me show you, let me run it. So when you run this function, what it does is it goes in the background and import all the models available in model library, in this case, all the classifiers, and it would fit it on your transform training set using tenfold validation by default. But if you want to change tenfold to fivefold, you can pass a fold parameter inside compare model. But essentially, this is giving you a starting point or a baseline position, right? And I'll wait until this finish. So at the end, this prints a grid for you. All the each row is an algorithm. So and each column is a metric. So 6 commonly used metric in case of classification. We have added MCC in the next release, so we have 7 metrics for next release. Just give it 10 more seconds to finish. Okay, so by default, this grid is sorted by accuracy, highest to lowest, but you can change the sort parameter simply by passing the sort parameter. So if your pass sort is equal to F1, it would sort the grid by F1. And it goes as far as highlighting the top performing metrics. So in this case, logistic regression is pretty much the best model based on all the metrics except for recall. In terms of recall, you can see QDA is actually doing quite better than logistic regression, but it's not very good on AUC or accuracy. But anyways, you got the point. It's gonna highlight all the metrics so that you can have an instant look and have a baseline without a lot of efforts, right? So it's just one word. Okay. There's another function that you'll find yourself using in PyCaret is create model. Excuse me. And create model is basically it creates a model using tenfold validation and evaluate all the metrics for you. So if you type create model LR, which means create a logistic regression, and these are results by fold, and this is the mean and standard deviation. And if you want to do it 5-fold logistic regression, you can just pass the fold parameter equal to 5, and this will be 5-fold, right? And there is a grid. In documentation, there's a table. So LR is the abbreviation for logistic regression, KNN for is K nearest neighbor, NB for naive Bayes. So there are about 15 or 16 estimators. Scikit-learn and non-scikit-learn as well. So for example, CAT boost, light medium, or XG boost is not scikit-learn, right? Okay, so here I'm creating a logistic regression model, tenfold. Here I'm creating a decision tree model, right? Very intuitive. Just like create model is for creating a model using default hyperparameters, tune model is basically tuning hyperparameters using a predefined search space, right? In 2.0, in 1.0, you cannot define your own search space. It uses predefined grids. But in 2.0, there's a possibility that you can pass your own tuning grids if you want, right? So very simple tune model DT based on tenfold cross validation, it gives you a result. In this case, my decision tree with default parameters performing 74% in AUC. After hyperparameter tuning, 86% of AUC. And if you want to see the difference, probably so you can see here. Next step, by default, it's set to none, but when you set it to 8, it's performing, it's optimized based on the predefined grid, right? Excuse me. Okay, so by default, when you tune any model in PyCaret, by default for classification, it's going to optimize accuracy function, but you can change it to AUC or recall simply by passing optimized parameters, right? So very intuitive. In this case, I'm tuning a naive Bayes model, but I want to optimize AUC. So there you go, 85%. The default night base was doing 84%, so a 1%. Okay, so similarly, and you can see that the changes because of this parameter var snipping. Okay, similarly, you can ensemble the model. So in this case, I'm passing my decision tree into ensemble model function, and what I get out of it is basically a bagged decision tree. So a decision tree wrapped inside bagging classifier. In this case, AUC bump up to 85%. My normal decision tree was doing 74%. So this is basically um, the result of ensembling. The other method for ensembling, if you want to use boosting, you can pass the method parameter is equal to boosting. By default, it's bagging. That's why I didn't have to pass anything here. And there are obviously default parameters set up. So, for example, number of estimators, how many estimators you build. By default, it's 10. If you want to change it to 100, you just pass n estimators is equal to 100. Do this. All right, so you see the 20 estimators, which is right. Okay. Excuse me. The other concept is blending, when you take individual models and combine their prediction using weighted average or some kind of non-weighted average, right? In this case, I'm creating three models: create model LR, logistic regression; LDL, linear discriminant analysis; GBC is gradient boosting classifier. I'm setting verbose is equal to false so that it doesn't flood my screen. All right, so now I have three models, and now I'm passing this model in a function called blend models. What it would do is it would generate the predictions from these three base models and build a voting classifier on top of that, right? Very simple. Perfect, 90% AUC. So when I compared my baselines, I've gone as far as 89.9 in logistic regression. Probably it's not statistically significant, but that's not the point here, right? And if you see my blender, basically blended estimators is just a blended model for these three individual models that we just created here, right? Okay, and to analyze your model performance, there's a function called plot model, which had quite a few plots, and it is as simple as writing plot underscore model. So you just pass your model into plot model. By default, it would give you a AUC plot, but there are quite a few plots. Again, if you check the documentation, yeah, the plots are listed here, right? So let me just quickly run them. This is confusion matrix, precision recall curve, validation curve, boundary plots. And here, if you notice, I'm just changing my model name, right? So this is the decision boundary for decision tree train model. This is night base, very obvious, and this is for Blender. Tightly overfitted. Okay, there's another function called evaluate model, which when you run evaluate model, it gives you this nice little UI. So it's the same thing. It would call plot model behind the scene, but if you're too lazy to just write plot model, just call it evaluate, and then you can use this UI to kind of navigate through. Right? Okay. There's another function called interpret model, which is basically an implementation of SHAP package in Python. And if you don't know about that, SHAP is a really good package that helps you explain your model agnostics. So here I have created, and it only works on tree-based models, so XGBoost, LightGBM, Decision Tree, Random Forest. Here I'm creating XGBoost based on tenfold validation, and I'm just gonna pass my XGBoost inside interpret model, right? By default, it would give you this plot, which is we would call it model agnostic. It's at an overall model level, but you can also check the correlation of features or You can also check the individual prediction reasoning, right? So in this case, I am asking XGBoost to plot a reason plot for me, which is it's also called argument plot for my observation number one in test set. And this is basically showing what influenced for this particular observation, what influenced the model prediction, right? Very useful if explainability is something you care about. And it has this interactive. Shapley has this functionality. If you understand this well enough, you'll be able to benefit from this. But there is a little bit of learning curve if you have not used SHAP before. You don't have the idea about game theory. You'll have a little bit of learning curve in the beginning, but that would be fine. Okay, so last thing really powerful here is this function called deploy model, right? And what this does is basically it takes your model and deploy it on AWS S3 bucket. In this case, I am passing my model XGBoost. I'm saying model name is XGBoost for AWS, and I'm authenticating, which is basically just giving my bucket name. And obviously you have to authenticate to AWS account using command line. So if you read the documentation of this function, there's instruction on if you are doing it for the first time, how do you set up the access key ID using your command line? And it's really simple. Okay, let me run this. There, model successfully deployed on AWS S3. So let me show you what it did. Right, so I am here in my S3 in my AWS console. Let me open my S3 account, and I have two buckets here. I'm gonna under PyCaret test, and this is the model that was pushed to AWS S3 with just one word, and it's a pickle file. And if I try to show you the model for a second, what is this? So let me show you what is this. Model boost ABC. And now let me load model. Let me show you what is it. So this is not just the model, right? This is the entire pipeline, and the last part of it would be a model. So this is the algorithm, but rest of it is basically all the steps that we have performed. Essentially, you have just defined them in setup. And when you initialize this setup, it constructs that pipeline and orchestrate that for you. So that when you have new data coming in, you don't have to replicate those steps. You just pass them inside predict model, which is a native function of PyCaret, and that predict model would pass the new observation through the entire pipeline. So even if you are doing feature interaction or feature engineering, uh, your new data set would not have those engineered features, right? It would have to be engineered on the fly. So this is gonna do that job for you. And for the next demo, the use case I have picked, I actually have that example. So you would see that we have created new features, and when you deploy it, it's not painful because we are essentially letting PyCaret do that for you. Okay. Excuse me. Okay. So, okay. And if you are following along, or if you want to see, there are 4 other notebooks here: regression, clustering, NLP, but they're exactly the same. I'm not gonna run them for you right now because obviously they're tight on time. But if you want to try it at your own time, it's really simple, right? There's nothing different. It's exactly the same as what we have just seen for classification. So I think what we should do now is jump to the second part of the session, which is more about deployment, and then wrap it up with 2 more demos for deployment. Okay. Okay, so excuse me. So what is deployment? So deployment of machine learning model is the process of making your models available in production so that somebody can use it. So imagine why we are doing all this, right? Normally we are doing all this so that somebody on the front end through a web application, through a software, through a mobile application, through an API or whatever, somebody can actually consume that model with the new data set coming in every day, right? I mean, in real life, it is unlikely that you would have CSV files to predict on. You would always have some kind of established pipeline, right? So whatever it is, a software, a web application, a microservice, an API, or a mobile, the idea of deployment is to whatever you have done in your notebook environment, you now have a model, which is essentially a file. How do you make that available to somebody on front end so that he or she can use the model to generate predictions on new data set and achieve the objective, right? So that's the whole idea, how to get your model from your notebook to somewhere where people can consume that model, right? So that's deployment. And when we talk about deployment, there are a couple of terms that you would hear a lot, and I'm gonna give you a very intuitive definitions today. So if you're coming from a very technical background, you would obviously have more detailed definition, but this is for somebody who have no idea about what is deployment, right? So very intuitive. So these are the terms that you would hear whenever somebody would talk about deployment. This is the term container, right? And you would hear that a lot. And what is container? So the most intuitive way to think about container is to think about containers on ship, right? And the ship, for example. And why there are containers? So that you can isolate content of one container from the other. That's exactly the same concept of containers in there, right? And if I give you one practical example, if you, I'm sure it happens with everybody when you are running a particular code, Python, Java, R, doesn't matter, on your computer, it works perfect. But when you ship that code to somebody, to your friend, it didn't work. If that happens with you, you have to understand why that happens. That happens because the environment on your computer is not same as the environment on the other computer, right? And what does environment include? Environment include the language itself, Python, R, Java, Go, whatever it is, the runtime language, and all the libraries, binaries, and dependencies, right? So when you install any package, it installs so many dependencies with it, right? And with every changing version, there is a possibility that you would conflict. So for example, you are using a library or a software A, which requires scikit-learn 0.21. And then on the same computer, if you are using package B, which requires scikit-learn 0.23, that's gonna be a problem, right? Because how would you do that? It would conflict. So the idea of containers is to basically isolate for each application, isolate it in a way that it doesn't conflict and it's transferable to other environments, right? Now you must be thinking virtual machines is essentially the same concept, right? I can have my one giant computer and install hypervisor and have multiple virtual machines running on my computer, and under each virtual machine I can have a conda environment and have all my dependencies there and have my application there, right? So this is kind of the structure. On your left side, this is the structure you must be thinking. If my goal is to isolate, well, why somebody invented Docker or a container, right? Why can't we just keep it simple, buy one machine, have multiple guest operating systems to hypervisor, right? On this structure. Containers is essentially doing the same thing. So the only difference, if you notice, between this on your left side virtual machine, on your right side is container, is basically in virtual machine for each application app 1, 2, 3, there is a guest operating system which is orchestrated by hypervisor. Here in container, there is only one operating system. So very basic answer to this, why use containers and not virtual machines, is containers are lightweight compared to virtual machine. Imagine installing 5 guest operating system versus just one operating system. Obviously, containers is really lightweight. They are portable and they are fast, right? So that's why. But the idea, if you are thinking, well, the reason you use virtual machine is to isolate, the idea is pretty much the same. But I just gave you an answer with merit why you should use containers and not virtual. Right? So what is Docker? So we talked about container, We talked about why you should use container as opposed to virtual machine. So what is Docker? Docker is the name of company who built a software also called Docker. And this software is basically it's a software to build containers. So we have talked about the idea of containers theoretically, but how do you do that? How do you do that isolation? Doesn't mean you create a folder and just install everything. It's not that, right? The way you containerize it is through a software called Docker, invented by or provided by a company called Docker, right? And while Docker is used very interchangeably with the word container, it's not the only container solution in the market. There are some less famous alternatives, LXD, LXC, that also does the same thing. But Docker, because it's so common, people use it interchangeably with term container. Right? But this is one of the containerization options. Okay, two more terms before we actually go and see the demo. Whatever we have done so far is inside our notebook, we have basically loaded the data set, created a transformation pipeline through setup, and we have trained multiple machine learning models, and then we finalized one, and then we have deployed it, right? But that's your model. On front end, there has to be an app, right? There has to be a form or some kind of input area where somebody would type in the new data and click on a button to get a prediction out of it, right? If you're thinking that simply. So you need to have a front end, right? And a web service where you can do that. Flask is the open source web framework. And what it does, it provides you tools and ability to build that web application. And it's not that hard, but if you're using Flask in order to build beautiful interfaces, you obviously need knowledge of HTML and CSS. And if you don't have that, you can use predefined templates for that, right? And we are going to use one of that today, so I'll show you. The other framework very popular these days is Streamlit, and it's very easy. It allows you to build lightweight web application like the rapid prototypes very quickly, and it's all in Python. So you basically write your normal Python code, and it's free, right? It's open source. Okay. So we have covered before we get into the demo. So we have theoretically covered what is container, how is it different, why is it different, and how is it different from virtual machines. What is Docker, and then Flask and Streamlit, which is basically uh, frameworks to build front-end web application, right? So in any machine learning project, broadly, you can break it in two parts, back-end and front-end. Back-end would be your model training process that would mostly happen offline, right? And your front-end would be your application, right? Okay, so let's get into the demo. Our first demo is deploying Flask app on Heroku, right? And this is the GitHub repository. You can clone that. I'm gonna show you the codes and everything, but if you wanna do it yourself, which I encourage you should do yourself, this is the repo you should clone. And if you don't have to code, you don't need to code, right? Everything is there. The pipeline is there as a pickle file in this repo. The front end is there. HTML is there. You just want to have the feel to do it yourself, so you can clone the repo. And before we get into this deployment, I have a use case. I have a separate use case for this. So first, let's go through the model training process so that you have an idea what we are building, right? Okay. So in the same repo, you would find a notebook called Insurance Model Training. Let me run this. This is the data set. This is a regression problem. You can see charges. You have to predict charges, which is a continuous value. So it's a regression problem based on all these six attributes, right? So insurance company, wants to predict hospitalization charges at the point where patient admits into hospital and hospital reports back to insurance company. And why would somebody do that? It helps them improve their cash flow forecasting process. Right? So very simple use case. We just have six features based on which we have to predict charges. Right? So this time I'm gonna import PyCaret.regression and initialize my environment. But this time you notice I'm doing few things differently. Right? I'm passing data, I'm passing my target variable, but I'm also doing these things. Normalize is equal to true because I want them, because the scale is different for the numbers, if you see. So I want to normalize it. So by default, it would convert these numbers into z-score of them, right? But you can choose min-max, and there are other methods as well. But in this case, I'm just converting into a z-score. I'm also setting polynomial features is equal to true and trigonometric features is equal to true. Feature interaction is equal to true. That means that I want PyCaret to create new features based on these six one that I have, right? And then I'm also asking bin numeric features. So I'm asking PyCaret to convert age and BMI into categorical variables by binning them, right? And it uses a rule called the Sturge rule by default, and you can read about that if you want. But I essentially it's me just defining it in the setup, right? And PyCaret would handle the rest of it. So let me just initiate this. So now if you see our original data set, is just six features. So that means on front end, when somebody would provide you with new data set, you'd only gonna have the six original columns, right? But the problem now is we have constructed a pipeline which has converted this six features into 61 features, right? But tomorrow, when business will provide you new data, you won't have 61 features. You still have six, right? So we'll have to have a process in place that would convert that six features into 61 features exactly in the same way that this pipeline is built, right? And now I'm gonna, and not just feature interaction, but also obviously normalize and transformation or anything that you do. So even this one, right? So tomorrow on the new data set, age would still be a number, 23. But this pipeline, when you run this code, this pipeline knows how to convert 23 into a categorical value. So that's all back in process. Okay, so let me just create a linear regression model, 81 R square solution. Not the most ideal, but still okay. I'm gonna save this. And we have seen this before. This is not just the model. This is the entire pipeline plus the model, right? And then you can use this pipeline to predict new data points, which we're gonna do shortly. Okay, so once we have this, let me open my development environment, which looks like this. I'm using Visual Studio Code. You can use anything you want. So here you know these two files already. Model training notebook, that's the notebook you have used to train. And this is deployment underscore 2804.pkl is the file we just saved using save underscore model function file, right? The new thing here is gonna be this file, app.py, which I'm gonna cover now. So app.py is just a Python script where we would use Flask framework, right, to build functions that we would call on front end, right? So here, the first section, just importing libraries. This is how you initialize your app in Flask, right? This is the name of the app. This is where you are loading model that you have just built using PyCaret. So notice that I'm not defining the full path because my app.py and this file is in the same folder, but normally you would do this, right? Whatever it is, but because it's in the same folder. I'm just loading it, right? Defining column names, and these are the functions. So this function here, home, returns me home.html, and we'll see shortly what is home.html, but this is basically a pretty beautiful front end page, right? And I didn't build it myself. I don't know HTML. I just imported a template from somebody and just edited that template, right? So you can use pre-made templates if you don't know HTML at all. But this is what it is. It's basically saying that as soon as somebody enter into this app, just render this page, which is home.html, which is in this folder, templates home.html. And if you come here, this is nothing but this is HTML headers, and this is the section that I edited. So this is nothing but 6 input boxes, right? 6 input boxes, and this is HTML. Okay. And this function here, define predict and predict API, is basically collecting the values from the form.values, and predicting those data points and returning one scalar value, which would be the amount, right? So this is basically same as if you were to use dot predict in Python, except the difference is you in production you won't have a CSV file to import in Python, right? You need a web service where you could send a request and get a result. So this is what it is. And even if you don't have a background in this, and this doesn't come to you very intuitively, uh, I'm still very certain you'll be able to copy this and at least edit it for your needs, right? And as you go along, you'd obviously have to dive deeper into different ways you can use these frameworks to generate your predictions, right? But in this case, this is just a 34-line Python file with HTML templates sitting here, right? And how does this app look like? So I'll go to my command prompt, right? And I'm gonna go to navigate folder. So here I have this file app.py, and I will just run it to my command line, and it would open this server on your computer. And if you navigate to this link here, this would basically open okay. So I closed that by mistake, sorry. There. So you see this page, right? This is that home.html. It was defining this purple color and gradient in the background, which I have absolutely no idea about. Just a template for me. And these are those 6 boxes, right? And what this is doing is on predict this button, there is a function that when somebody clicks this button, this goes in the background, call those functions that we have created here, and basically use this file, pickle file, pass it through the entire transformation pipeline and return me the number. So if I fill this age column, sex male, BMI 10, children 0, smoker yes, region ASD, doesn't matter. It goes in the background and return you this scalar value, which is basically you doing that dot predict in Python, right? It's the same thing, but now it's a front end because normally people would consume it this way, right? And now, because this application is working on your computer, and you can see 127.0.0.1 5,000, this is my local address. Problem is you cannot, like, even if you do that, nobody else can use it, right? It's still on your computer. The last part is when you have your training done, which we have done, and saved the deployment pipeline, you have built your front-end app. The last part is to push this app on cloud so that other people in your organization, or if it's an open project across the world, people can consume that, right? And for that, we will use Heroku. So Heroku is a cloud platform that provides you the ability to kind of push your app to cloud, right? And when you sign up for a Heroku account, I think you get 500 or 600 free hours. So you can do it pretty much for free. And in the presentation, there are 5 steps how you can push your application to Heroku. I'm going to skip that because I'm going to show you live. So let me first close my thing on my local. Let me get out of it. And I'm going to go to Heroku, log in, right? New, create new app. Let me give the name PyCaret demo 99. United States, create app. Now, all you have to do is this folder, all these files has to be pushed to Heroku. And there is a really simple way to do that. You upload this files on GitHub. So for example, this path here, this repo, this repo here, this is where I have uploaded my entire code, right? All I need to do, you don't need to upload your code on Heroku. All you need to do is select GitHub, type your repo name, connect to your repo, and deploy. That's it. As soon as you click on deploy, it is going to take 10-15 minutes, but it would deploy. And here at the end, it would give you an address, a web address that is accessible over internet. So in order to save the time, obviously you cannot make 15 minutes. I already have published this app beforehand, PyCaret-demo1. And if I show you this, PyCaret-demo1, this is basically the same app that you have seen on my computer on 127.0.0.1. This is now available on internet for people to use. So if you go to this app on your computer, you would be able, you should see the same application. Obviously, it's a free service and I'm pretty much out of my credits. So it's gonna take some time to open, but but it should work, right? I'm still waiting for this to open. Okay, so this one. For first time it would load, but then it should be fine. There you go. So this application is, if you notice, it's not on my local. This is uploaded on Heroku, right? So it should work just like, there you go. And now, because this is web service as well, you can use it. If I go back, you can use it in Python to generate a request to this URL. So if I run this code, it's going to return me this, which is prediction. So if you don't care about front end, you don't want to build this purplish beautiful page. You just want to throw your model out on internet and allow people to consume it through API. You can use it that way too, right? But obviously, if you're consuming it in production, you're not going to use Heroku or any other free service, obviously. Okay. Excuse me. For second part, I don't think so we'll be able to cover AWS Target completely, but I want to show you Streamlit app, right? So here we have talked about Flask and Streamlit. What we have seen now was Flask, right? But Streamlit is another framework, and using the same use case, I'm going to show you an app for Streamlit, right? And let me show you the app first so that you have. Okay, so this is the same problem, but this app is created using Streamlit, right? And it's really simple. I'll show you the code for this, but it's essentially doing the same thing. You fill in the values, a little bit more fancy. You click on predict and you get the value. And in this application, I've also built a batch system. So if you upload a CSV file, it would run through a CSV file and give you a label column, which is essentially prediction, right? Uh, and I did this in like a few minutes. And if I show you the code of this, this is it. Really simple. Loading libraries, loading model, creating a predict function that I would call in my main function. And this is basically showing the logo and showing that sidebar here, right? And if you are doing online, like if you select this box as online, this section of app will load. And if you select batch, this section of app will load, right? The idea is you start really simple. So when I start building this, I had nothing, but I had this, right? And then I only had this one. But then as you start building it, you just wrap it around your if analysis statement to control the display of the screen, right? That's the idea. So you have seen one app in Flask. This is another framework called Streamlit, and it's really easy, very intuitive. You just write normal Python, so you don't have to learn anything new. I've not used it yet, but I think you can also write HTML in the stream. So you just paste your HTML code in here, which is kind of messy, but it kind of gives you a very uh, rapid ability to do a rapid prototyping here, right? Okay, so we have seen this app. Now, if you noticed, for Heroku, we have theoretically talked about container and Docker, but we didn't do anything here in terms of container and Docker, right? Because in Heroku, they have their own base image, and they would use their base image and would just run your application. If you are lucky, it would work, but in production or in real life, you don't want to do that, right? You don't want to run your applications on any base system. You want to have your own environment, which is your own container, which is your own Docker, right? So you want to have a container. And how you build that container is simply by putting, and you might get disappointed, simply by creating a file in your folder, and the file is called Docker file, right? The file name is Docker file, and this is the file on my screen. All this file is doing, if you read this, this is like an instruction. This is like an instruction that from Python 3.7 environment, do this, run pip install virtual env, do this, create a directory, run pip install requirements file, copy all the files, expose the port 8501, and then run Streamlit run app, which is basically your endpoint or runtime, right? So this is just instruction. What happened is when you push this, if you have a Docker file in your folder, and if you have Docker installed on your computer, you can push this file or build an image and push this on registry. Now, every major cloud service provider have their own registry. So Azure would have container registry, AWS has its container registry, Google has its container registry, and there's an open source container registry of Docker as well. But what you would do is you would build a Docker file and you would push that on the container registry, and then spin off an app based on that. Right now, we don't have enough time to cover that part here, but I can show you at least the starting part, and then there is a tutorial that you can follow, and it's extremely, extremely simple, right? So if you have an AWS account, what you have to do is create an Elastic Container Registry, right? You have seen I have already created one, but when you log in for first time, you don't see anything. You click on Create Repository, and let me just create demo two. And when you create a repo, you see something called View Push Commands. So what code you have to run, AWS will also give you that. So when you click on View Push Commands, you get this 4 lines of code here, right? This is you are logging into service. This is you are building a Docker image. This is you are tagging, and this is you are pushing. So you basically have to just run it in your command prompt, right? And after that, you have to create a task, a cluster and task. But essentially, at the end of this process, you would get a web address, in just like Heroku, you would get a web address where you would be able to see your. So it doesn't matter where you deploy. You deploy on Google, AWS, Azure. Many times it's a decision for it's a decision based on several factors. What other services your organization is using. Cost is also obviously part of decision making. What are the use case? Are you completely native to one cloud provider, or you're everywhere, right? So whatever cloud service provider you would pick, the idea is essentially same. You would use some kind of registry to run your containers, and then push it as an individual instance, or push it using Kubernetes clusters. The idea is same. So in this case, I'm gonna call it off, and we'll be open for Q&A. I realize we just have 15 minutes now.
Thank you very much, Moez. That was a very interesting presentation. So there's a few questions already. I have a couple of questions too, but why don't I start in order here? So we have a question from Kamal asking, does PyCaret support AutoML too? If not, then how does it differ from DataRobot or Google's AutoML?
Yeah, so this is a good question. Everybody thinks PyCaret is AutoML, but with 2.0 release, what you would realize is PyCaret is not a AutoML solution. It is in fact, it allows you to create your own AutoML. So PyCaret is a first modular automation system where you would write code to create or customize your own AutoML. The difference with DataRobot is PyCaret is open source. DataRobot is expensive. Google AutoML is also it's paid tool. It's not open source.
Okay, thank you, Moez. We have another question here. Is there something like predict proba as in scikit-learn to predict probabilities in case of binary or multi-level classification?
Yes. So if I have this juice example already open, so I already have this open. Let me pick any model. So let me create a model, LR. When you predict model LR, when you predict it, you would realize that you have 2 new columns here, label and score. Score is your predict proba, label is your like label 1 or 0, like actual binary labels. So score is basically same as predict proba. And if you also want to call it, so this LR object is basically a scikit-learn object. So if you want to use the native methods from scikit-learn, you can just use it. Like for example, predict proba should be here somewhere here. So if you want, you can use it. So we are not stopping you to use the native methods, but you also have this flexibility of just using PyCaret directly. So the difference here, if you notice, what you get back is your original data set with these 2 columns. So this is still a human readable data set, right? Okay.
Very interesting. Okay, so we have a question here. Are there plans to include deep learning support in PyCaret?
Not at this point. And I personally don't, there's a huge demand for that. But I personally think deep learning is its own area. And I think Fast API Fast AI is doing essentially the same thing that we are doing with canonical machine learning.
Okay, so I have a quick question for you as well while we're on this subject. So I noticed that, for example, when you were showing us the comparison of all of the algorithms, do you also show comparisons of different hyperparameters within each algorithm, or how are you selecting the optimal hyperparameters for a given algorithm?
So good question. So when you just run compare models, it would use the default parameters, right? But you can tune the hyperparameters using tune model function and get all the iterations back from that function. But when you just run compare models, you get vanilla default parameters for all models.
Okay, thank you, Moez. Okay, we have another question. Does PyCaret take care of categorical variables? That is, can we specify ordinal, nominal, PD dot dummies, etc.?
Sure. So by default, PyCaret would just do one hot encoding for categorical variables based on whatever we infer. But there are 5 other types of encoding. So there is definitely you can choose whatever type of encoding for categorical variables.
Okay, great. We have this question. So do you see PyCaret as an alternative for scikit-learn or a wrapper package over scikit-learn?
It's definitely a wrapper. It's definitely a wrapper.
Okay, and while we're on this question, that's a great question. Thanks, Melvin. So, and Moez for the answer. So can we also ask, so it's scikit-learn, but I remember you also indicated there's a few other libraries on which also you kind of have this wrapper extending over. XGBoost is one. Which are some of the other ones?
XGBoost. So in 1.0, XGBoost is one. CatBoost is another one. LightGBM is another one. But the original vision for PyCaret, which 2.0 would satisfy to great extent, was not to create a wrapper for like existing libraries. Otherwise, there is no value, right? I mean, if we just wrap scikit-learn around, there's no value. The vision is to basically use PyCaret as kind of a template. So in 2.0, what we also allow, and it's really powerful, to bring your own models. So as long as if you have your own algorithm and as long as it follows fit predict API, you can use that in PyCaret. So for example, in 2.0, you would be able to do genetic programming in PyCaret because you can use GP-learn with PyCaret, right? So that's the idea.
Okay, very interesting. We have another very interesting question from our colleague Alexei. So does PyCaret support custom, that is user-written tasks in its pipelines? I mean, this would be very important in enterprise settings. So is that supported?
Not at this point.
Okay, and what about in 2.0 or the future versions? Would that be something you'll consider?
2.0 would be a lot more flexible, compared to 1.0. But if you are talking about full-fledged Spark pipelines, I don't think that's going to happen soon. But we are providing flexibility to a point where you can replace the pipelines. At this point, you don't have visibility to backend of PyCaret unless you want to go into source and read the code. But in 2.0, we are providing a lot of utility functions, which would provide developers ability to change a lot of things in PyCaret.
Okay, so speaking of utility functions, that brings up a question I had, Moez, if I may, at the start of the presentation. So I know you mentioned that, in the real world, of course, you're not going to have people manually uploading CSV files, and there needs to be some mechanism to connect to existing sources of data. So what are some of those sources of data, if you don't mind reminding us? Do you do a normal database type connections? Do you do S3, WebDAV? What are the connections that you currently support?
So basically, PyCaret is Python library, right? So any connection that you can establish in Python, you can use it. For PyCaret, it doesn't matter where the data is coming from. As long as you give us data frame, we'll work with that. How you get that data frame in Python, it's completely up to you. So if you can connect, and I'm pretty sure like in Python, you can connect to most of the data sources, right? So
absolutely. Okay, another quick follow-up question for you is, so you made an interesting comment that currently, even though the vision is to sort of have that template-based approach and support many different libraries, but one interesting question that comes up is that for a library that doesn't naturally support parallelization, for instance, like scikit-learn out of the box, that's not really where you're going with this. So it's not like you are getting into scikit-learn and spinning out different instances of it and then sort of managing that parallelization. It's whatever the system supports, the system supports.
So so scikit-learn has like it would support default parallelization, but it would not be distributed like a Spark cluster, right? It would do parallel computing but only to an extent algorithms allow it, right? For example, it doesn't allow parallel processing in all the algorithms. So if scikit-learn algorithm is originally allowing that, we'll use it, right? If it doesn't, we are not scratching the algorithms to make them distributed.
Okay. So I think that wraps up the questions we have, Moez. We really want to thank you for taking the time to talk to us about this. I know tomorrow you're doing another conversation on another YouTube channel. So I think it's great if you mention again the name of that channel. I think people that have interest and will learn about PyCaret 2.0, that'll be great.
Yeah, sure. So if you are already using PyCaret or plan to use tomorrow, you must attend this because 2.0 is really next level. And tomorrow, for the first time, we are gonna talk about that. And the data scientist, where the channel where I'm presenting is Abhishek Thakur. So in this presentation, let me just put up the link. In fact, you know what? I'll post it on my LinkedIn again tonight. So if you are following me on LinkedIn, you would be able to see. But if you are using PyCaret or interested in using, you must attend tomorrow. It would be really exciting.
Thank you very much, Moez, for coming and sharing your knowledge with us. We hope to have you back in a couple of months when PyCaret 2 has really taken off and you're already thinking about PyCaret 3.0. Thank you.
All right. Thanks, Vic. Thank you, everybody, for attending, and have a good night.
Yes. Bye for now.
Bye.